Hello students, welcome back to my channel, and today we are going to learn class 12 vector algebra chapter, and the topic is component of a vector. So our first topic is component of a vector. Components of a vector. For this we need to draw the mutual perpendicular system. This is x, y, z. Think about the, obviously this is origin. Suppose this one at equal distance from origin. We are taking this one as 0, 1, 0. This one 1, 0, 0, and this one 0, 0, 1. Means in all three x's we are taking 1 unit. Okay, we are taking 1 unit measurement, and then we are taking this like this arrow signs towards that side from O. Origin is the initial point. I'm giving this name. This is suppose A, this is B, and this is C. Then from this figure, OA vector is equals to this side OA vector. So its modulus is equals to 1. Similarly, OB vector's modulus equals to 1. OC vector's modulus equals to 1. It means these three vectors, OA vector, OB vector and OC vector, these three vectors are unit vectors. Unit vectors along x-axis, y-axis and z-axis. These three unit vectors are called, or you can say notated as, this is denoted as I hat, OB j hat and OC vector k hat. These three are the general notations. I hat, j hat, k hat. Somebody can write down I vector, j vector, k vector, doesn't matter, same thing. Especially for unit vectors, we use a different symbol, that is cap. That's why I cap, j cap and k cap. Now these three are the three unit vectors along x-axis, y-axis and z-axis. Coming to its elaborated figure, that is that cuboidal shape. Cuboidal shape we want to draw. So this is the cuboidal shape. This is the origin O. This side x-axis, y-axis, z-axis. This point in the space is P, general point, whose coordinates we are taking it as x, y, z. What does it mean? It means from O to A. Suppose this is A. This I am giving as B. This one C. This one to P already is there. This is D, E and F. Now you all know that OA will be X. Its magnitude will be X. OB will be Y and OC will be Z. Because of this coordinate P of x, y, z. Okay. I'm adding OP. So OP is the vector, that is R vector. R vector is the position vector of the point P and it will be towards OP. Okay. Now it can be easily written that X is the magnitude, that means the scalar we can say, and this side's unit vector is I cap. So we can write OA here, not for the last figure. Last figure is different, this figure is different. For this figure, we can write OA vector is equals to X I cap. Now, how OA vector is equals to X I cap? That means multiplication of a scalar to a vector. This already we have done in the previous video, so you can go and check the description box. Links will be given over there. So OA vector will be xi cap, that means this is xi cap. OB vector will be yj cap, and OC vector will be zk cap. Okay. These will be three vectors along x-axis, y-axis and z-axis. Depending on what? Depending on the point P, x, y, z. That means depending on the vector OP vector, or you can say depending on the vector R vector. That means these three are three vector components of R vector. These three are vector components of R vector. X, Y, Z, only X, only Y, only Z. That means the numbers, that means the scalars. Scalars X, Y and Z. These three are the scalar components of the vector R. Okay. And we can write, and it can be easily proved by Pythagoras theorem and all. And here this is resultant. So R vector is equals to xi plus yj plus zk. Okay, so this is the final expression, and by Pythagoras theorem or distance formula we can easily prove that this will be x square plus y square plus z square. That means we can say that modulus of R is equals to root over of x square plus y square plus z square. So this is the components of a vector. Okay. Now there are some of the properties you can say, or the results based on addition and subtraction of vectors. So think about that A vector is equals to A1 I plus A2j plus A3k, and suppose B vector is equals to B1 I plus B2j plus B3k. Then when we are adding A and B, then each and every scalar components will be added. When we are subtracting, each components will be subtracted from the first. Okay, that means normal, we will just take common, but it is not actually common. Rather, we can say that the writing procedure is to write like common. So it will be A plus B vector is equals to, please don't miss to give vector sign. Without vector sign, that will be taken as a scalar, and that will create a problem. So A vector plus B vector is equals to A1 plus B1 I cap, A2 plus B2 j cap, A3 plus B3 K. Okay, and similarly for subtraction also. Now there are equal vectors. So these are for subtraction and addition, same. Now equal vectors, when we are calling two vectors equal, suppose A vector is equals to B vector, that means each and every scalar component will be equal. Each and every scalar component will be equal. That means we can say A1 will be equals to B1, A2 will be equals to B2, A3 will be equals to B3. All scalar components will be equal. Okay, so this is the equal vectors property or equal vectors condition. Then coming to number 4, that is multiplication of vector by any scalar. Okay, so I'm taking it as lambda. Suppose lambda A vector. Now A vector, lambda A vector. So lambda A vector will be lambda into A1I plus A2j plus A3k. Can you see it? Okay. That means lambda will be multiplied to each component. Lambda A1I plus lambda A2j plus lambda A3k. Like this. Okay. So it will be multiplied to everything. Now there are some results, or you can say some of the properties depending on this scalar and vector part. So the first one, there are 3 in your book. K A vector plus M A vector is equals to obviously K plus M A vector. Don't put dot or cross sign for writing into. Don't put it. Number 2, KB vector plus MD vector. KB vector plus KA vector is equals to K into B vector plus A vector. Okay. And number 3, suppose K into MA vector, you can write only Km into A vector, or you can write M into KA vector. So there are these 3 properties for multiplication of a vector by a scalar, and these are 3 only. So I hope you all have understood up to this, and the next topic we will be actually doing some of the examples now. Our next topic number 1, we have already done or talked about collinear vectors. Okay, collinear vector symbol, suppose A vector and B vector are collinear vector, then we can write down A vector equals to lambda B vector, where lambda is, can you see? Yeah, where lambda is a scalar. Okay. Now we all know that A vector can be written as like this: A2j plus A3k, and B vector lambda into B1I plus B2j plus B3k. If we compare both the sides and taking all different components together, then we will be getting a1 equals to lambda b1, a2 equals to lambda b2, and a3 equals to lambda b3. From all 3 points, we can write down a1 by b1 equals to lambda, lambda equals to a2 by b2, and lambda equals to a3 by b3. So this relation can be written. That means if we are getting this type of relation, we can say that the vectors are collinear vectors. The vectors are collinear vectors and its condition will be this. And if we are getting this, we can directly say that the vectors given are collinear vectors. Okay? Then the second one. Number 2. Suppose a vector equals to, the expression is a1i plus a2j plus a3k. In normal way, any vector's scalar components are representing the direction ratios of the line or of the vector line. If it is in normal vector form, then scalar components are representing direction ratios of the vector. Rather, number 3, if any vector it is represented with element or cos alpha into I cap plus cos beta into j cap plus cos gamma into k cap. It's in this way, so you can see that any vector, if its scalar components are represented with direction cosines, then the vector must be a unit vector. This will be a unit vector. So a non-unit vector, scalar components will represent direction ratios, and a unit vector's scalar components will represent direction cosines. So this is the simple thing that you need to remember. Okay. Now we will go to some of the examples which are very related to and very important to this topic. So I have written the question for you. The question tells that write the direction ratios of the vector I cap plus j cap minus 2k cap and hence calculate its direction cosines. Okay. So when it is given in vector form, how we can find out direction ratio and direction cosines? It's very easy. Just look at the process. Direction ratio is what I just told before this one, that for a vector, normal vector, its components will be direction ratios. That means direction ratios are 1, 1 and minus 2. These are direction ratios, right? Direction cosines with a vector. So let r vector is equals to I cap plus j cap minus 2k cap. That means mod r vector is equals to root over of 1 plus 1 plus 4. So it's root 6. So mod r is equals to root 6. That means L will be 1 divided by root 6. M will be 1 divided by root 6. And N will be minus 2 divided by root 6. So these three will be the direction cosines of the line. So this is the way we can find it out, direction ratios and direction cosines. So next topic is vector joining two points. Okay, vector joining two points. We will draw the mutual perpendicular system ones x, y and z. Okay, think about this is a point and this one is a point. So we will draw its position vectors like this with dotted line I am drawing. And this one I am adding like this. This is O. Can you see it? Yes. This is O. Suppose this is P and this is Q. P I am taking as x1, y1, z1. Q I am taking x2, y2, z2. These two are two given coordinates. Okay. Now, from the triangle law, this is PQ, OP and OQ. From the triangle law, that means triangle OPQ gives us OP plus PQ is equals to OQ. OP vector plus PQ vector is equals to OQ vector. Okay. That means PQ vector is equals to OQ vector minus OP vector. OQ vector is equals to x2i plus y2j as z2k minus OP vector means x1i plus y1j plus z1k. Now normal vector subtraction that already we have done, what it will be? It will be like this. It will be x2 minus x1's I cap plus y2 minus y1's j cap plus z2 minus z1 k cap. Okay, so this will be, you have to write it in one line. Okay, I didn't have space here, that's why I have written like this, but that must be written in one line. x2 minus x1 into I cap plus y2 minus y1 into j cap plus z2 minus z1 into k cap. That means this vector's magnitude, this vector, that is PQ vector's magnitude, can be written as scalar components whole squares addition. x2 minus x1's whole square plus y2 minus y1's whole square plus z2 minus z1's whole square. So this is PQ and this is actually magnitude of PQ. So this is the vector PQ and this is the magnitude of PQ, and we need to find it vector joining two points. So the vector joining two points P and Q is this and its magnitude is this. So I hope you all have understood it. Okay, and this is all about today's session, students. We will meet in the next video with any other topic on vector algebra. So till then, thank you and bye bye.